So Bohr thought it was a great idea to really examine what was going on. He was in the right place at the right time, and some people think that some of what he came up with was accidental and it happened to work, and then he built a whole theory off of this. This happens in science plenty of the time. So what Bohr was dealing with going into the idea is that there was a lot of pushback from scientists saying that what we understand of the world, which by the way is classical mechanics, this is what, if you take physics and you're dealing with objects and friction and gravity, that's classical mechanics. It's dependent on the gravity of the earth and different forces that are known on the earth acting on different objects. So if you take that view of the atom, it is flawed because it predicts something that doesn't happen. The first thing it does is it predicts that negative electrons, which everyone agreed at that point that electrons have a charge, and everyone agreed that they moved. What it says is in classical mechanics is that an accelerating charge will emit radiation, but there are plenty of atoms sitting there not emitting radiation. So that was the first problem. And the second problem is that they also began to understand the idea that electrons are continuously are moving and they're continuously attracted to that positive nucleus. And so they wanted to know why the negative electron will not continuously spiral into the positive nucleus, because they were dealing with the ideas of circles and circular movement. Well, why isn't it spiraling in and destroying every nucleus? So what came about was quantum mechanical descriptions, and you have to be really, really, really advanced to even be dealing with quantum mechanical equations and just everything related to quantum mechanical stuff. But it is a very active field right now. You can find recent articles and a lot of interesting information in the press about quantum machines and quantum movement. So you are definitely welcome to go ahead and check that out. You might find it very, very interesting. But at the time, they actually had to develop and work with brand new ideas. And one of the reasons that it is different is because classical mechanics, again, it's depending on the gravity of the Earth. And the pull between the nucleus and the electron is so many magnitudes stronger than the pull of gravity. So the electron is dealing with the pull of the nucleus, and the nucleus is dealing with the pull of the electron. So that's just a completely different field than basing everything on the pull of gravity. So Bohr began all these calculations using information given by the hydrogen spectrum, and he realized something really important. He could predict the spacing between the excited hydrogen electrons and the nucleus, and he could do it consistently. And he showed it to everyone else, and everyone else agreed, hey, you are doing this consistently. You are right. You can tell us where these electrons are. They were all really excited, except for the fact that his equation of the line spectrum of hydrogen would only work for one electron systems. For example, it will work for hydrogen, it will work for helium plus, and lithium 2+. Yep, so basically it works for 3 types of atoms. One of them is an atom neutral and the others are ions. So people still really needed this idea though, because he supported some work that was being done with Einstein and the idea of quantized energy states. So everyone began adopting his planetary model because, well, in one way, it's easiest to draw. You will see as we get into quantum mechanics, it gets to a point where you can't just draw an atom very easily at all. So Bohr's model, and this is the model you would have seen since you were very, very young, it has a nucleus in the middle and it has an electron on the outside. So since this is hydrogen, in the nucleus we only have a proton. We don't even have any neutrons in that one, and the electron is spinning around. And he says that there are 4 possible energy levels, and when electrons get excited, they jump up. And then when they stop being so excited, they fall back down. We're going to do some more with this soon. So he addressed this idea of the flaws, but he wasn't completely correct. So he says that the electrons are still orbiting, but their energies are quantized so that they do not crash into the nucleus or spiral into the nucleus. And he designed it as they followed planetary style orbits. So he said the electron could be here, or it could be here, or here, or here. And that's what quantized means. It means that it can only be certain values. You'll know this from math whenever you have something where they're like n equals 1, n equals 2, n equals 3, you got a whole series of them. That's kind of like saying you're quantizing something. It just means that there are discrete places it can be and discrete places it can't be. If this stuff is starting to feel a little crazy, just you wait until they figure it out.